We have this video going over lesson 1.4a, alternate interior angles. So my name is Mr. Hilgert. I'll be going through the lesson with you. Just copy down the notes as I go through them. There's going to be a couple times where I ask you to pause. So just pause the video, discuss with your partner whatever it is that we're doing, and then unpause it once you've talked about it for a second and continue watching the video and see how you did. So we're on page, I believe, page 49 in your books. Let's get right down to it. So activity number 1, talking about angle pairs here. It says find the measure of angle JGH. Explain or show your reasoning. So angle JGH, remember the way we list out angles is an endpoint, then the center vertex, and then another endpoint. So JGH means I'm starting here, going here to the vertex G, and then continuing on to the other endpoint, which is H right here. So they're asking for this angle. Okay. I know from what we've talked about the past couple of weeks that the angle that they give us, this 30-degree angle here, has a vertical angle over here, which is 30 degrees, okay? And I get that by doing a 180-degree rotation around that center vertex G. So if you guys remember, we had a thing where you copied this out with your patty paper, you spin or rotate it 180 degrees, and you see that those angles actually do match up. Okay, well, to spin or turn something 180 degrees, let me erase all this that I've got here, that would mean that I'm taking this line segment from F to G. When I turn it 180 degrees, it's going to end up, I'll do it in a different color, it's going to end up on the same line, just it's continuing the line on, right? That's a 180 degree rotation. I know that those segments should be the same there. That means this angle here total is 180 degrees. So we need to find this angle in here, knowing that part of that 180 degrees is already taken up with this 30-degree angle that's written in here. So to find what's left to get to 180, we could just do a subtraction. 180 minus 30. And that gives us 150 degrees. So there's the answer to number 1. It does say to explain or show your reasoning, which, that's what I did. Okay. I already answered number 2 also in my explanation. It says find and label a second 30-degree angle in the diagram. Well, if you remember, I had that up here. It's the vertical angle to the 30-degree angle that they give us, FGJ. Okay. It says find and label an angle congruent to angle JGH. Well, that would be this angle that is vertical to the one that we found, right? It would be this one. The one thing I do want us to practice is labeling these angles. So let's go ahead and write that out for number 2. It says find and label a second 30-degree angle in the diagram. I put where the 30 degrees goes, right? It's this right here. How do I write out that angle? Use the angle symbol and then start at an endpoint, go to the vertex, then go to the other endpoint. So I would go HGI for that angle. For that angle that also measures 30 degrees. For the second part of that question where it says find and label an angle congruent to angle JGH, I already labeled it. It's right here, the 150-degree angle, but let's actually write it out. And it is, start at an endpoint FGI. So angle FGI. All right. What we're going to do is use that knowledge of how we find these vertical angles to understand what happens with these intersections that you see down below. Okay. So here, activity number 2, the title kind of gives you what the keyword means. So it says cutting parallel lines with a transversal. And then it says keyword, transversal. So a transversal is what the activity kind of says there. It is a line that cuts through cuts through a set of parallel lines. So in this example that we have off to the right here, line L and M we can see are parallel. At least we're going to say that they are. So line L, which is this line right here, and line M are parallel. So the line that cuts through those is line K. Line K is the transversal. So just go ahead and label that. I have a little drawing there so that you can see that. Now what happens when a transversal cuts through two parallel lines is it forms these angle relationships, and that's what we're getting into at the rest of this activity. It says here, so now that we know what transversal means, we can actually answer this question. It says here, lines AC and lines DF are parallel. They are cut by the transversal HJ. So you can see that there. Here's line AC. Here's line DF, and then line HJ would be the transversal that cuts through those, okay? With your partner, find the 7 unknown angle measures in the diagram and explain your reasoning. So go ahead, pause the video right now, look at what we did for activity 1, and see if you and your partner can find all the missing angles on this diagram. Go. Okay, so now that you've unpaused the video, let's see what you came up with. I know that if at this vertex point B, this angle right here is 63 degrees, then that also means that this angle is 63 degrees because those are vertical angles. I can do a 180 degree rotation and those lines will, or those angles will match up. How do I find the other two angles from that? Well, remember, to rotate it 180 degrees, that means this line here is the 180 degrees. If that angle we know makes up 63 of those 180 degrees, then what's left is what's going to go right here, and this for this angle right here. So to find that, we need to do a little subtraction. 180 minus 63. And when I do that, I get 117 degrees. So let me erase my little stuff I got going on here. This is 117 degrees. Then this angle is vertical to that angle, so it is also 117 degrees. But that still leaves us with all 4 of these that we didn't know. But because these lines are parallel, if you guys remember what we've talked about the last few weeks, if this line and this line are parallel, I can translate that line to the other. And in fact, if you were to trace out this intersection, oops, I erased my degree symbol. If you were to trace out this intersection here with your patty paper, you would see that when you translate this line AC up, so if I take this and I translate it up and to the right, I guess it goes to the right a little bit as well. Look at that. It forms the exact same angles, which makes sense. Those lines are parallel. Oops, I forget my camera is backwards. There we go. These lines are parallel, right? They're just at different heights. The angle that cut, or the line that cuts through them, is going to form the same angles at both intersections. So these, oops, these are the same, and these are vertical angles here, the 63s, and then I have this as 117. Well, the angle vertical to it is also 117. So that's how we can look at that. Using your patty paper helps. Okay, but hopefully you don't have to use your patty paper every time. Hopefully you can kind of see that if these lines are parallel, then yeah, the same angle has to be formed when a line cuts through both of them. For question number 2, it says, what do you notice about the angles with vertex B and the angles with vertex E? I showed you that when I slid up my patty paper. When I slid that up, you guys could see it matched up perfectly. The angles are exactly the same. So the angles are the same. To continue on with that, if you guys turn to the next page, it says here, using what you noticed, find the measure of the 4 angles at point B. So what did they do? They gave us this angle right here, this angle up at this intersection at vertex E, and it is 34 degrees, but they're asking us to find all these angles on vertex B. Okay, now they gave us an important piece of information here. Line AC and line DF are parallel, meaning that line GH, that's this line right here, is gonna cut through both of those at the same angle. Okay, so if that's a 34-degree angle they gave us right here, that means this is also going to be a 34-degree angle. And again, you could use your patty paper and translate that down and see that. Yeah, this is the same angle. Okay, this is 34 also. Those are vertical angles. To get the missing angle, so I know this would be a complete 180 degrees. I just need to subtract 34 from 180. So I'm going to do that off to the side. 180 minus 34. And that gives me 146 degrees. So this angle is 146. And this angle, which is vertical to that angle, is 146. Now, I said they gave us some important information at the end of that one because look, for question number 4, it says the next diagram resembles the first one, but the lines form slightly different angles. And you guys can see that, right? These are not vertical angles. Or sorry, these are not parallel lines. I'm still going to have vertical angles. I'm not going to have congruent angles, okay? It says here, work with your partner to find the 6 unknown angles with vertices at point B and E. They did give us enough information, so go ahead and pause the video, see if you can find these missing 6 angles. All right, let's see what you came up with. I'm going to start up here at vertex E. So on vertex E, they give us that this angle is 108 degrees, which means this angle, which is vertical to it, I would get that from a 180-degree rotation, is also 108 degrees. To get the missing angle beside it, I'll do that in a different color. This angle right here, I need to subtract 108 from 180. So I'm going to do that. 100 and, oh, what am I trying to draw? 180 minus 108 gives me 72 degrees. So if this one is 72 degrees, we know that the one below it, the vertical angle to it, is also 72 degrees. But I can't just transfer that down, right? You try to copy this down with your patty paper, and I'll show you what I mean. You try to, I didn't want to erase all of that. Oh well, I'll erase all of it. If I have this intersection traced out on my patty paper, okay, and I slide this down, look at that. It doesn't match up, okay? I've got the one line, I've got the transversal line matching up, but the other one doesn't. And this is what happens when the lines aren't parallel, okay? So I can't just say, oh, I knew all of these measurements up here, now I can just put those down there, right? And we can see that's not gonna work. So let's figure out what these are. Oh, it's the same measurements that we had before. They gave us the 63 degrees. There's my vertical angle that's 63 degrees, which means these are also vertical angles to each other. 117 degrees for both of them, okay? It says, what do you notice about the angles in this diagram as compared to the earlier diagram? Well, with the earlier diagram, the angles were all the same. For this diagram, they're not. And when I say all the same, I mean at the 2 different intersections, they were all the same. But at one intersection, we had different numbers this time. If I filled those back in here, this was 72, this was 72, and this was 108. So we can look at those numbers, and they're not the same at the 2 different intersections anymore, but that's because now they have non-parallel lines, So they're not going to be the same angle. How are the two diagrams different? So I would say one set has parallel lines, the other doesn't. One set has parallel lines. The other doesn't. How are they the same? I think that's the harder question to answer. How are they the same? They're the same in that they do still both have vertical angles at each intersection, right? That's not going to change whether the lines are parallel or not. We still have the vertical angles, okay? So they both have vertical angles that are the same. Both have congruent, I'll use the math term, vertical angles. All right. So what we're going to introduce next is alternate interior angles. So there's the key word. Alternate interior angles are angles that are inside the parallel lines. Inside the parallel lines, but on opposite sides of the transversal. And intersections. Ran out of room. Accidentally hit the page up button. Let's go back down to that. Okay, so what do I mean by that? Angles that are on the inside of the parallel lines, but on opposite sides of the transversals and intersections, or transversal and intersections. So when I say opposite intersections, I mean they're not at the same intersection, right? Like this one, for example, had two intersections, had this one at E and this one at B. And when I say on opposite sides of the transversal, I mean one's on one side of the transversal, the other one's on the other. So this is what it looks like. Okay, I've got, for activity number 3 on the next page, this drawing. It tells us that the two lines are parallel. So I know all the same angles are going to get formed at the two different intersections. And you guys can kind of see this now. I've got my parallel lines, and I have angles that are in between the parallel lines, which would be this one, this one, this one, and this one, because they're between the two parallel lines. But then I also have angles that are outside the parallel lines. And if I did those in a different color, those ones that I'm referring to would be this one, this one, this one, and this one, okay? So the blue, those are inside. We use that word interior in math. The red are outside. We use the word exterior in math. So I've got alternate interior angles. So let's erase the exterior ones. Don't need them. I've got alternate interior angles. Alternate meaning they're on opposite sides of the transversal and at opposite intersections. Okay. So, for instance, these two right here, those are not alternate interior angles. They are interior. They are in between the parallel lines. They are on opposite sides of the transversal, but they're at the same intersection. They happen at this same intersection right here. Okay? Let's go ahead and see what they're having us do with these with these two parallel lines crossed by a transversal. It says lines L and K are parallel, and T is a transversal, which we knew. Point M is the midpoint of PQ, of line PQ. Find a rigid transformation showing that angles MPA, that's this angle right here, and MQB, this angle right here, are congruent. Now those are alternate interior angles. They are in between the parallel lines, they're on opposite sides of the transversal, and they're at the two different intersections, opposite intersections, okay? We're going to show how we can get those to be, or we're not going to show how they can be. We're going to show that they are congruent by doing rigid transformations. Remember, that's how we prove that two things are congruent. How? Trace this out on your patty paper. I'm going to do this in a different color real quick. I'm going to make this one, let's make this one blue down here. So remember where these are at, okay? The blue one's on the bottom, red one's on the top. If I trace out my lines on my patty paper in green, I'm going to try and do it exact. Be patient with me here. I'm going to trace out my lines in green. And I do a 180-degree rotation around point M. That means the transversal, I'm just going to keep spinning it until it ends up back on itself. Right? That's a 180-degree turn. So let's see if the iPad will cooperate with me. If I spin that 180 degrees, boom, right there, so that I almost got it. Give me a sec. There we go. Almost. That's as good as I can get it with the iPad. You guys can actually do better with your patty paper, believe it or not. Okay? When I do that rotation, that 180-degree rotation, look at what happened. Blue was on the bottom, remember? Red was on the top. But when I did that rotation, they fit perfectly, but blue is now where red was. Red is now where blue was. I just proved that they're congruent. I just did that rotation, that 180-degree rotation, to get those angles to be in the position of the other color. So find a rigid transformation showing these angles are congruent. Just did it. Rotate 180 degrees. Remember, when you say rotation, you have to say how many degrees, which I did, around which point and which direction. But I don't have to when it's 180 degrees. I don't have to say direction, because it doesn't matter if you go clockwise or counterclockwise. You turned halfway. So rotate 180 degrees around point M. That midpoint, right? That's how I got it to end back up on itself. Says for number 2 here, says for number 2 here, in this picture, lines L and K are no longer parallel. M is still the midpoint. Does your argument in the earlier problem apply in this situation? Okay, well, let's see. I'll just trace it out. Try and be as exact as I can. See if the iPad will help me out here. Let's do red on top, blue on the bottom. Okay. If I spin this 180 degrees, I just spin it till the transversal lines up back on itself again, right? I have, well, it doesn't match up. I mean, even if I could get the iPad to cooperate, which you guys can get your patty paper to cooperate for sure, I can't get it to match up. I mean, you can see that. My green lines aren't anywhere close to those two lines that are not parallel now, right? And that's the whole point. When they're not parallel, you don't have alternate interior angles. But when they are parallel, those alternate interior angles are congruent. How can we prove that? Through a rigid transformation. We take 180-degree turn around the midpoint of that transversal line, and that's going to get us that those two alternate interior angles match back up, and that they are then indeed congruent. Okay? So does my argument in the earlier problem apply in this situation? Whoa. Let's change it to the pen. No, it does not. No, it does not. That only works. That only works if we have parallel lines. Parallel lines. Yeah, I know my handwriting's terrible. It's just not that easy to write on the iPad. And then I think that's it. Yeah, that's it. So you guys are ready to get going on your assignment. Your assignment is on page 52. As always, if you have any questions, just make sure you ask your teacher. All right, good luck.